Hey guys, over the next couple of videos, we're going to be taking a look at the human immune system. And I think it's really important to recognize that even in a time where we're so fortunate to have a great deal of medical understanding and knowledge and a lot of tools to treat disease, it's really important to understand that our body's immune system is really our best defense against pathogens, disease-causing agents. What we're going to try to do over the next couple of videos is to take a look at the two divisions of that immune system. Our immune system can roughly be considered to fall into two groups. First is what we call innate or non-specific immunity, and that's what we're going to talk about today. We can also take a look at acquired or specific immunity, and we'll take a look at that in a later video. Now, our innate immunity is really something that can respond to any sort of pathogen. It can respond to whether it's viral or bacterial or a worm or anything like that, fungal. Now, we can divide the innate immune system into two principal divisions. First off, there are going to be things that prevent the entry of pathogens, simply barriers, ways to stop us from getting sick. And the second are going to be things that fight pathogens once they get inside our body. Now, the innate immune system is something that's working for us all the time. And a lot of our behaviors in everyday life can let you know how important that innate immune system is. Now, for example, the first barrier that we should take a look at is pretty simple. It's our skin. Your skin is an amazing barrier against the entry of pathogens. The oil that's on your skin traps pathogens. The pH of the secretions on the skin helps to kill pathogens. And the skin itself simply serves as a barrier to prevent pathogens from getting into our bloodstream. Think about what happens if you get a cut. You immediately try to clean that cut out, and you usually treat it with something to kill bacteria like alcohol or iodine or neosporin or some sort of derivative like that, and then you cover it up. You put that barrier back on. You wouldn't just leave a big cut exposed to the air, and you especially wouldn't just take a big cut and drag it through dirt. Those sort of things are an invitation to get pathogens inside the body. Now, another barrier that we don't necessarily think of, but that's also tremendously important, is the barrier of mucus. Mucus, yeah, snot, sludge that kind of comes up out of our respiratory passages. This stuff actually is helping to protect us. Now, mucus is secreted by cells in the respiratory passages in the lungs, and it serves to trap pathogens that happen to get into us. Now, pathogens that get stuck in the mucus along our respiratory passages are pushed up and out by the use of ciliated cells. Cilia are those little microtubule structures, remember, that act kind of like oars. And those push all of that mucus and all the trapped particles up and out of your nose. So if your nose is running, it's really that there could be things trapped in there and we're trying to push it out. Now, you can see evidence of this. If your nose is running and you really have an infection, the mucus will often have a color to it, and that's a sign of that infection. Without the activity of the ciliated cells, the pathogens can get stuck very deeply down into our respiratory system, and that could lead to serious respiratory infections. Now, one other thing that's important to notice in terms of a pathogen or a barrier is actually the hairs that are in your nose. Believe it or not, nose hairs are kind of important for blocking pathogens. They serve to increase the surface area, and they act basically like a little filter. Regardless of how clean you are and what your grooming standards are, everybody has nose hairs. And in fact, your nose can trap a very high percentage of the pathogens. So if you're ever sitting on that airplane with the person next to you coughing, it's probably a better idea to be breathing in through your nose rather than your mouth, because you have a better chance of trapping some of those pathogens before they get down into your lower respiratory tract. The last barrier that we're going to take a look at is that of your stomach acid. Now, your stomach acid has a very low pH, and that low pH serves to kill the vast majority of bacteria and other things that make it down into our stomach. No matter how fastidious we are about being clean and washing our hands before a meal, or washing our vegetables or cooking our food thoroughly, there are bacteria in the food that you're eating. And those bacteria might cause some sort of infection or difficulty if it weren't for the stomach acid. Your stomach acid is very, very good at killing those bacteria and preventing infections. In fact, things that are specifically pathogens that affect our digestive tract, those have developed in ways to actually overcome that barrier of stomach acid. For example, things like tapeworms, their eggs actually have basically a little coating on the outside that gets dissolved away in the stomach acid, and they don't actually hatch until they make it through your stomach and down into your small intestine. Now, building on the subject of tapeworms, it's kind of a hard act to follow, but we're going to take a look at ways that our body deals with pathogens once they get past those barriers. Now, one of the first responses that our body has are things that are called cellular responses. Cellular responses, as the name implies, are cells that serve to fight against pathogens. And the most obvious category of those cells are things called phagocytic cells. Now, you may recall from earlier in biology that phagocytosis is the endocytosis, or taking in, of a large particle. It's literally cellular eating. So phagocytosis is a cell engulfing something that's relatively large, like a bacterial cell or another pathogen. Now, there are three types of phagocytic cells that I want to bring up. First are macrophages, which are large and migrate through the body, or they can reside permanently in areas where pathogens will likely be trapped. For example, some parts of the lymphatic system, like your spleen or lymph nodes or something like that. Now, these macrophages are, as their name implies, macro, large. They're really big, and they act almost like amoebas within the body, reaching out and engulfing pathogens that might be nearby. A couple of other phagocytic cells are neutrophils and dendritic cells. Now, neutrophils circulate in the blood and enter sites of infection or injury, whereas dendritic cells reside in tissues that touch the environment, for example, our skin, and serve as sort of a quick response force. But again, they're all phagocytic cells, and they're all helping to attack pathogens in basically the same way. Now, natural killer cells are another type of cellular antipathogen. Natural killer cells release chemicals that induce apoptosis. Apoptosis, or programmed cell death, is basically a form of cellular suicide. If a cell is showing signs of a pathogen infection, a natural killer cell can release chemicals that cause that cell to go through apoptosis. And that orderly destruction of the infected cell could lead to the destruction of the viral particles that are inside that cell. And it's important to draw the distinction between apoptosis and just lysis, or breaking open the cell. If we broke open the infected cell, the viral particles are going to spill out. What we're trying to do is kill that cell in an orderly way so that the viral particles that are inside the cell are trapped, die. Well, they don't die, they're not really alive, but they cannot spread further and infect more cells. Think about the movie Alien. You don't want to let the alien just pop out of and run around and kill more people. You want to stop it before it can spread. Now, natural killer cells are activated by chemicals that are released by active macrophages. And these are critical in terms of controlling viral infections. Now, another set of responses that our cell has to pathogens that get inside of our body is what are called non-cellular innate immune responses. Non-cellular innate immune responses don't involve classes of cells. One of the first and most obvious is something called an interferon. As the name suggests, interferon is a chemical that interferes with viral infection. A viral infection in one cell can cause neighboring cells to release interferons. These chemicals interfere with viral reproduction and are basically one of our best ways to fight against a viral infection. Synthetic interferons can be used sometimes as antiviral drugs. A system to protect against bacterial infection is something known as the complement system. Complement is a set of proteins that circulate in our blood plasma, and they're generally in an inactive state, but they can be activated by proteins on a pathogen cell surface. And when they're activated, a combination of more than one of these proteins can end up basically attacking the pathogen cell membranes and leading to lysis or bursting of these bacterial pathogens. Another non-cellular immune response is what's called the inflammatory response. Now, the inflammatory response is not where you stand up and say something outrageous at a meeting designed to provoke a response. The inflammatory response is basically that redness and swelling that's associated with a little minor cut or scrape. You can see this scrape on my arm. That redness and swelling is due to the fact that I have increased blood flow in that area. When you get a damage to an area, cells known as mast cells release a chemical called histamine. Histamine causes dilation of nearby blood vessels, and it also allows blood vessels to become more permeable. The dilation of the blood vessels increases blood flow. That's why you get redness. That's why you get swelling. The leakiness of those blood vessels is what causes, well, kind of a clear liquid sometimes to ooze out into an area of a scrape. That clear liquid is blood plasma, as well as some of the macrophages and other cells that are going to be fighting an infection. Macrophages and neutrophils can exit blood vessels at the site of the infection, and the cells can also release cytokines, chemicals that further stimulate blood flow in the region, complement proteins to fight pathogens. All of these things are working together because we have that increase in blood flow, and that increase, that like swelling and redness and heat, as all a result of that increased blood flow. Now, you may have heard of histamine before because you might take an antihistamine if you have allergies. Antihistamines fight against histamine, and an allergic response is actually an immune response against something like pollen that's in the air. If you have redness in your nose, it feels swollen or itchy, that's because of the histamine being released, causing an inflammatory response in the nose. So antihistamines tend to shut down that response. And this is why antihistamines will reduce redness and swelling and things like that. Now, fever is another method of fighting against infection. Activated macrophages release chemicals that cause the body to raise its temperature. Raising the temperature interferes with viral growth, interferes with bacterial growth because it denatures proteins. Anything that counts on surviving by multiplying rapidly is going to be thrown off by being at a temperature that's not ideal. The bacteria that infect us are designed or have evolved to be most effective at body temperature. If we increase our body's temperature, we don't feel good, but the bacteria really don't do well. And since they rely on being able to multiply very, very quickly in order to basically keep up with all the cells that are being destroyed by our immune system, if we can throw off their rate of growth, they really don't do so well, and it gives our immune system a chance to fight back against them. So even though you may feel rotten when you have a fever, the bacteria probably feel worse, and it's really our body's way of trying to stop their growth, or at least slow it down so that our immune system can catch back up. So I hope that in looking at the immune system, you've been able to see a couple of ways in which our body is fighting against pathogens all the time. Some of the things that I've talked about, hopefully you might have noticed a little bit in your day-to-day life. Things like fevers or inflammatory responses are things that we are so used to from the time we're very, very young that we don't think anything of them. And yet, they're truly important things to help us in our fight against pathogens. In an upcoming video, we'll take a look at acquired immunity and how our body can fight off a specific pathogen instead of just pathogens in general. I hope you'll join us then. Take care. Have a great day.